This video is on percent composition. Percent composition is the percent by mass of each element in a compound. So percent composition is the mass of the element in the compound, so the mass of just that particular element, divided by the entire formula mass for the whole compound or molecule, and then you just multiply by 100. You're going to have a decimal basically, and you're going to want that decimal turned into a percentage. So you're basically taking, the decimal you have in this first fraction and multiplying by 100% to make that decimal into a percentage. Okay, so let's try an example. Silicon dioxide is the main component of glass. What is the percentage by mass of oxygen in silicon dioxide? Okay, so silicon dioxide is 1 silicon and then O2 for dioxide, right? If there's 2 of the oxygens, we need O2. This monosilicon is implied. It's implied that there's 1 silicon, but we drop mono from the beginning of the name. Okay, so we've got SiO2. So step 1 is going to be to figure out the formula mass of that SiO2. So figure out your formula mass. Okay, so for SiO2, I've got, I've got 1 silicon and I've got, 2 oxygen atoms. So 2 times 16 AMU for oxygen and 1 times 28.09 AMU for silicon. Okay, and I need to add those two together. And when I do that, I get 60.09 AMUs for for every SiO2 molecule. Okay, so that's my formula mass. My step 2 is going to be to really, find out the, percent composition with this formula. Find out the percent. I can go ahead and write out percent composition. So find the percentage that is oxygen in silicon dioxide for our example. So what percent is oxygen? Well, the 2 times 16 AMU. So I rewrite the oxygen line, or the portion that's oxygen. So there's 2 times 16 AMUs. That's the part that is oxygen. Divide by the total, or the 60.09 AMUs, dividing by the total formula mass. So I did just the part that's oxygen, the 2 times 16, divided by the total formula mass, the 60.09. I'll have a decimal then. It's actually 0.5325, it looks like. But I need to multiply that decimal by 100%, really to make it into a percentage, or 53.25%. I'm like out of room for my percent, but that should say percent. Okay, so that's an example of how to find percent composition. Let's try some more examples. What is the percentage by mass of carbon in propane? So I've got C3H8. Okay, so I'm going to need the total formula mass. So let's do that as our step 1. So we'll do our carbon count and our hydrogen count. We have 3 carbons times 12.01 plus we've got 8 hydrogens times 1.008 AMUs each for a total of 44.09 AMUs for our formula mass. Okay, so step 2 is we'll do the percent that is carbon. Okay, so what percent is carbon? Well, the 3 times 12.01 AMUs, that's the part that was carbon. We'll divide by the total formula mass, the 44.09 AMUs, and we'll take it times 100%, really converting this decimal into percentage form. Okay, and when we do that, you should get, oh, by the way, AMUs on the numerator and the denominator cancel out for percent composition. That's what makes it a percentage. It's this ratio, right? And so in a ratio, the units in the numerator cancel out with the units in the denominator. So these AMUs are canceling. And then we should get 81.72%. Okay, let's try another example. So let's see if we can move me out of the way here. How about right there? That'll do. Okay, what is the percentage by mass of oxygen in acetaminophen? The acetaminophen is the painkiller that the name brand is known as Tylenol, right? Okay, so what's the percent mass of oxygen in this formula? Well, first we need to find the formula mass. So let's do 8 carbon atoms. We'll do 9 hydrogen atoms. We'll do 1 nitrogen and 2 oxygen atoms. Okay, 8 times 12.01 AMUs for carbon, 9 times 1.008 AMUs for hydrogen. We've got 1 times, on our periodic table, we've got 14.01 AMUs for nitrogen, and oxygen is 2 times 16 AMU. And so when we total that, we should get 151.16 AMUs for acetaminophen's formula mass. Almost got me like a tongue twister. Okay, so we need to know the percent that's oxygen. So this is our step 2, by the way. Step 1 was formula mass. Step 2 is percent composition. What percent of this is oxygen? So basically, it's the oxygen line. 2 times 16 AMUs divided by the total was 151.16 AMUs. Okay, so when we do that, this would give us 0.21 and change, but we're going to multiply by 100%, right? Because we're going to make this decimal, those cancel, this decimal into a percentage. So in percentage form, it's 21.17% oxygen, right? That's how much oxygen is in acetaminophen, 21.17%. Okay, let's try at least one more. Actually, I think we've got 2 more. It says octane. Okay, well, these are different. This is a different type of example. Octane is 15.9% hydrogen. It's like giving you the answer. What is the mass of what mass of hydrogen is in a 4.52 gram sample of octane? Okay, so here's a strategy for getting the percent composition already, is that I like to first take this percentage and convert it back to decimal form. So taking the 15.9% and going back to decimal form, you could take 15.9% and divide by 100%. That very last step was to multiply by 100% to get it to percentage. Going back to decimal form is the opposite. You're dividing by 100%. Are you going back to decimal form? 0.159. Some people see that as just like kind of moving the decimal two places to the left, and it's 0.159. Okay, so now we're in decimal form. In step 2, all you have to do is take that decimal form, that ratio, if you will, times the total mass, times the mass that you've been given. So what we're going to do is take 0.159 times the 4.52 gram sample we've been given, and 0.719 grams of that is actually hydrogen. So we're saying, it's saying about 16% of this is hydrogen. What's 16% of 4.52? Well, it's 0.16 or 0.159 to be exact times 4.52. So that's the way that if you're given the percentage, you can figure out how, what portion of that does that percentage really relate to. Okay, so sugar is 42.1% carbon. What mass of carbon is in 2 kilograms of sugar? This would be a great place to pause and try the example we just did. Try to apply the same thing to this problem. Did you pause and try? Okay, Well, let's give it a try together. Okay, so step 1 was to convert the the percentage back to a decimal by dividing by 100%. Getting into decimal form, you could call it. You know, some people just see it as moving the decimal 2 places, but we're going into decimal form, 0.4210, and we're going to multiply that decimal form times the total. Oh boy, I'm missing a 1 here. Times the total is 2 kilograms, and you will get 0.842 kilograms is carbon in the sugar. Woohoo, that's it. Okay, so that concludes how to calculate these percent compositions and also other problems, like if you're given the percent composition, how to figure out the mass that is associated with.